Okay. Okay, so I'm going to review setup and draw. We actually haven't really been using draw a whole lot in the semester so far, but you guys have probably seen it before because it's usually what shows up whenever you start a new sketch. So I'm going to increase the size a little bit here. Um, okay, so when we start a new P5 sketch, we have these two functions, setup and draw. And so far, we've just been doing static sketches, sketches that don't have any animation or interaction. And so we've been doing everything in the setup function. Just to make it kind of simpler, if things aren't moving or if they're not changing over time, we don't really need this draw function. And so I'm going to talk about that a little bit now as we start talking about interactivity and using our system variables. So our setup function runs once. So setup runs once to set up our sketch. So anything that we do in setup function, it's just going to happen once at the beginning of our sketch. And so that's why we have create canvas in here. We don't want to create the canvas over and over again. We just want to create one canvas and then we can keep drawing on it. And we can also do other P5 stuff in there, like set the background or draw shapes, draw colors, and set up different variables and things like that. But we don't want anything that's going to be changing over time to be in our setup function. So that's what the draw function is for. And so the draw function is going to run repeatedly, redrawing our graphics for as long as the sketch is running. And the default is to go at 60 frames per second. So that's pretty fast. If you guys play video games, you're probably familiar with FPS, how often something is rendering. And the default for most video games is they're trying to get up to 60 frames per second because that gives us kind of like a very good level of motion fidelity. You may remember from like MMP 100 or maybe an animation class, sort of the idea of frames per second. And you have, in order for motion to look real, you kind of have to have something that's like between 15 and 20 frames per second. If you go under that, you start to see like kind of the gaps in between the frames. And of course, the faster you get, the better kind of like fidelity there is in that motion. So that's kind of the difference between setup and draw. And we can kind of show that difference by adding in some system variables that will show how things kind of move. So I'm going to do that real quick. I'm going to skip ahead for a second. Or actually, yeah, I'll just use this example. Oh, I see what I did. Okay. Yeah. Okay. So yeah, I'm going to skip ahead a second. I'm going to explain this more in a second, but I'm just going to draw something in the draw function. So I'm just going to draw an ellipse here at 50, 50, 50, something like that. So there's our ellipse. It's just sitting there. It's not moving. So we don't really actually need a draw function to make a sketch like this. If I commented out everything in here and just run setup, it's still going to look the same because nothing's moving. But if I take advantage of one of our system variables, which is a frame count, and a frame count is basically how many frames our program has been running, and I run the program again, this time with the draw function, now we're going to see that our circle is moving across the canvas. So what I'm doing is I'm plugging in this frame count as the x value to the circle, and that means that the circle is constant, that x value is changing every time we redraw the canvas. We are drawing the circle in a new place. And because it's going fast enough, it looks like the circle is animating. It looks like a simple animation. And that's basically what we're going to be utilizing as our method of creating interaction. So let's take the background out for a second, and you'll see a little bit more what's happening. But actually, let's put, since I have the dark background on my website, I need a light background at least once. So here I'm just drawing the background once, and then I'm drawing my ellipse. And notice there's this like trail of ellipses going across the page. And so we can see what's actually happening is that one ellipse is being drawn, and then we see the next ellipse and it's going across the screen. And when I put that background back in, then we just see the ellipse because the background is being drawn and covering up all those other ellipses. So let's do another example. I'll put an alpha value in the background. Let's put a little less of an alpha value in the background. So you can kind of see this like trail behind the ellipse. I'll have to do like a really small one. Okay, so now there's a little transparency. We can see that the background is slowly covering up the previous ellipses. So when we're doing draw, it's constantly changing. It's constantly redrawing itself. And when we put a background in there, we're covering everything up that came before it. And so that's how we can create things like interaction and motion in our sketches. And that's basically, how you would create animation or any type of interactivity that you would have in another program. So let's go back to our system variables for a second. Um, oh, I guess I have, this seems out of order, but oh, I guess, okay. Let's come back to this because let's come back to scope in a second. I think we need some more variables before we talk about scope. Okay, so let's talk about our static system variables. So static means that, again, something that doesn't change, versus dynamic, which means that it changes over time. So our static system variables are things about our environment that are going to stay the same. So one of those variables is width and height, or two of those variables rather. When we create a canvas, we set the width at 400 and the height at 400. And that gives us access to those values for as long as our program exists. So if I go down here and I console.log width and height, we're going to see that that is equivalent to whatever we put inside of our canvas, those two, that 400 and 400. So if I run my sketch again, there you see the width is 400 and the height is 400. If I change the width to like 600, now you can see our width is 600 and our height is 400. And so those numbers don't change because we only create the canvas once, but they're very useful. So let's put our background back in and let's see, let's imagine something that would be useful to do now that we know the width and the height. Like if I wanted to create a frame that matches the size of my canvas, I could draw a rectangle. And so let's say I wanted the rectangle to start at like 2020, but then I don't know how far it should go, right? It might be like, 400 and 400, but that doesn't quite make it all the way across my sketch. So what I can use instead is the width and height variables, which relate to the size of the canvas. So I'm going to turn on no fill here. And so if I wanted my rectangle to go all the way across, instead of 400, I could say width. And so now we're going all the way across, but we're going a little bit over, right? Because we started at 20. So I'd have to subtract 20. And then we're getting right to the edge. So actually, I would want to subtract 40. So 40 is just 20 times 2. We can create a little margin. And so now we have a rectangle, a sort of frame that matches our width and height. So if I make this larger, it'll still match. And if I make it smaller, then the frame will still match. And I can do the same thing with my height. So I can say height minus 20 times 2. And now I'll get a nice even frame that will be the same no matter how big my canvas is. So if I change the height, my frame has the same proportions. If I change the width, my frame has the same proportions. So these system variables are really useful if you want to create a sketch that has that takes up the whole canvas, or is centered on the canvas, or uses these values in other ways. So let's take a look at some other things that we could do with this. So here's another example. I can place an ellipse directly in the middle of my canvas. So let's get rid of this moving ellipse for a second. So if I wanted to put an ellipse directly in the middle of the canvas, I could use the values. So I could say, I know the canvas is 600 by 600, so I could put my ellipse at 300 by 300. And for now, let's just make it small. So I'll make it 50. And let's do the fill here. Okay, so now it's centered, but I had to do this math by myself. I had to look at the number and divide by 2 and then plug the number in here. Um, so if I decide to change my sketch, if I make the width 400, now my ellipse isn't centered anymore. Since I changed the size of the canvas, that value doesn't work anymore. And I'd have to go back and do the math again. Another way to do this is just take the width, and actually I'm going to use a variable here because it'll make it a little bit easier to read, I think. So you could just plug this directly into where the argument is right here. But to make it a little more readable, I'm going to say variable x, and I'm going to say width divided by 2. And so now if I plug in x here, now you can see my circle is centered again. And I can do the same thing on the y. So I can say variable y is height divided by 2. And now if I put in y here, it'll be centered. And again, the same thing. If I change my canvas size, so if I make this 400 by 400, see that the ellipse stays centered within my little frame here. So I can also use this for the size. So let's say I have an S variable, and let's say I just want to make the ellipse the same size as my canvas. I can say S equals width, and then just put S in here. And so now my ellipse is the same size as my canvas. Again, if I change the size of the canvas, let's make it bigger again. Now the ellipse gets bigger. Now the height and the width don't match. So the size, you can see it lines up with the edges on the right and left, but it's going over the top and the bottom. So if I wanted to keep it inside, I could change that to height. Or if I wanted to include the margin, I could say height minus 20 times 2. And so now it'll line up with the frame as well. So the width and the height are useful values to be able to change our design to kind of change with the size of the canvas and fit different types of layouts. Okay. So let's keep going. Okay, so in this case, I'm going to make like a checker pattern with my rectangles. So let's take a look at what that looks like, and then we'll do it over in P5. So I'm going to leave the ellipse here and add to this. So I'm just going to keep making more variables here, even though they're going to be overwriting each other. Since I'm using var, it doesn't really matter. So for my first rectangle, I want to match it in the top left corner. So I'm going to say variable x equals 0 and variable y equals 0. And now I want to make my rectangle half of the width and half of the height. So I'm going to make a variable called w for width, and I'm just going to set that to width divided by 2. So notice that in the first example, I said x equals width over 2, and now in this example, I'm saying w equals width over 2. So width is just the width of the canvas, but I can use that value to set any other value that I want. It's not necessarily tied to the width of a shape or the x position of the shape. It's just a value that I can use for either one. So then let's say h equals height over 2. And now we can draw our rectangle. So we can say rectangle at x, y, width, and height. Okay, so there's our first rectangle. And so now I want to make a little checkerboard. I'm going to take out my ellipse for a second. And so there's a couple ways that I could do this just with the variables that I already have. So I could say rectangle. Let's just put another one in here for now. X, Y, width, and height. Okay, so if I want to move it over, and actually I want to do a little drawing. So let me get out my pen here. All right, there we go. Okay. And let me plug in my stylus thing. Okay. Okay. So here's it's a little hard to see because it's black. Let's turn this to white actually. So let's turn this off for a second. And let's do fill is white. Okay. So right here is my xy, which is 0, 0. This point right here. And then the width of this rectangle, W, is the width of the canvas divided by 2. So the width of the canvas over 2. So the width of the canvas is from here all the way across to here, and divided by 2 is right there. So that's how I get the width of that rectangle. Then the height is pretty much the same thing. The height is from 0 here all the way to whatever this is. That's height. And my rectangle is h, which is height divided by 2. So if I wanted to draw a rectangle down here, I already have all the numbers I need to be able to draw this. And I just have to figure out how to put them together. So I know what this value is, right? It's W from here to here. And I know what this value is on the y. It's down here, so this is h. And then this width is the same because it's width over 2, and this height is the same, so it's height over 2. Okay, so there's a couple ways I can express this. This is kind of a simple example, but I can say x plus w, and that will move my rectangle over. And I can say y plus h, and that will move my rectangle down. Since x and y are 0, you might be thinking, can't I just do WH, WH, and that would be correct. And so notice that this can be kind of confusing because I'm using the width inside the x argument, but it's still being applied to the x value for the rectangle. So even this looks like a w, the name of the variable is not what's important here. What's important here is the order that it comes. So a rectangle is always going to be x, y, width, and then height. So even if I put a w here and an h here, I'm still going to get the x and y values from whatever is stored inside that w and h variable. So I like to express it like this, x plus w and y plus h. So it makes it a little bit more clear what I'm doing here. I'm taking the x value that I started with, and I'm adding the width, and I'm taking the y value that I started with, and I'm adding the height here, and then I'm still using width and height as the width and the height of my rectangle. So again, with variables, we can name them whatever we want. Like if I named this w here banana and then plugged in banana in the right places, it would look exactly the same. Except that I didn't do it right. How did I? Oh, because I didn't put banana over here. There we go. Okay. So it doesn't matter what you call the variable. If it has the right number in it, it'll do the right thing. But there are conventions for how we name our variables to make it easier to read our code. So x always refers to the horizontal position, y always refers to the vertical position, w, width, usually refers to the width, and h usually refers to the height. For the ellipse, I use size because I was using it for the diameter. You could also use diameter or d for diameter there. But we usually use variables that sound like or look like the things that they're being used for to make it a little bit easier to read our code. So let's keep going, looking at these examples. So in this one, we're using a grid. We're creating a little grid with lines instead of rectangles. And so this one is pretty much the same thing, except I'm drawing lines. So I'm defining x1, y1, x2, y2, and then drawing across the canvas. So I'm kind of running out of room to do examples here. Uh, let's see. I guess I can just do I'll just do another sketch just to go through the math on this one real quick. So let's copy this. Okay. So let's just go over the math on this. We don't have to write all the code. So let's just look at each one of our points in our lines. So I'm just going to delete this example here. And then, so our first x1 is width over 2. So remember, the canvas is the width. So that's width, whatever that value is. And so our x1, which is this point right here, x1 is width divided by 2. Okay, so that makes sense. That's how we get here. So it's width over 2. And then our y1 is just 0. So 0 makes sense. It's up at the top of the canvas. So that's how we get the first point of this line. And the second point of this line is down here. And so the x value is going to stay the same. Notice that x1 and x2 are the same thing because our line doesn't move horizontally, it just moves vertically. So our x1 is the same thing, x2 is width over 2. And now our y1 is just height because it goes all the way to the bottom of the canvas. Okay, so that's our height right there. And then this line going across is the same thing, but just turned around. So you'll notice patterns a lot like that as you start to create graphics using variables. So, oh, whoops, how did I do that? Okay, so x1 over here equals 0. And our y1 in this case is height over 2. Okay, so we take the whole height and then we divide it by 2, and that's how we get the y. And then over here, it's the other way around. So x2 equals width, because we're going all the way across, and y2 still equals height divided by 2. So that's the math on that one. Okay, let's continue. Okay, so those are our static system variables. Actually, one more that I want to show you real quick for static system variables is there's values window width and window height, which will just take the width and height of the window itself. And that can be useful if you want to make a sketch that's full screen. So we can look at the reference for that one. So window width. So this is basically how you'll see that used most of the time. So let's use it in this example. So if I change this to window width and window height, so the grid stays the same because I was using width and height, and those update to whatever we plug in to our canvas. But the window width gives us the actual width of this window. In this case, it's the preview pane. If you had it on just a blank web page, it would just be however big the browser is. And then the window height here, obviously, is just the height. So if I change the size of the window and I run the sketch again, it's going to change to fill that space. So that can be really useful if you want a sketch that actually fills up the entire space in your browser window. Okay, so now we're going to look at dynamic system variables. These are variables that change over time. And we'll start with the mouse position. So the mouse position on your computer and as it's sort of registered by P5 in the browser is constantly changing. And P5 uses mouse X and mouse Y to capture that. So we can use that to, in this example, we're just gonna draw a line in our program. So I'll use this example here. And so we need our draw function for this. So let's introduce that. Hold on just a second. How many is this going to be? Okay. That's okay. Sorry about that. Okay, so we're going to draw a line using mouse X and mouse Y. So I'm going to put a draw function in here. So this example didn't have a draw function, but I can just write one in. So I'm just going to say function draw. And to start, I'm just going to draw an ellipse at mouse X, mouse Y, so you guys can see what that looks like. So I'm going to say ellipse, mouse X, mouse Y for the X and Y position, and then I'll just say 50 for the size. And so now you can see there's my ellipse moving around on the screen. And you can see that it matches the position of the mouse. It's maybe a little bit behind as the drawing is catching up with where the mouse is, but you can see that it's actually changing based on that position. So let's draw a line taking advantage of that. So I'm going to capture X, so I'm going to say variable X equals mouse X, and variable Y equals mouse Y. And so again, this isn't really necessary. You can see that I can plug in these values really easily here, but this makes it really clear what I'm using these for. I'm using them for the X and Y position of my drawing. And so now I'm just going to draw a line. Let's see, how did I do this? So we'll say line X, Y, and 0, 0. So this is just going to draw a line from the origin point of the sketch to wherever my mouse is. But we can add to that by using other values. So we also have the P mouse X and the P mouse Y. And so if we use those, it's going to give us the previous position of the mouse. So let's add those in. And so I guess at this point, I'm just going to sub them in. So let's get rid of those variables. And let's just say mouse X, mouse Y, P mouse X, P mouse Y. Okay, so, and let's get rid of the ellipse so we can see it. So now we're going to see a line that just follows where our mouse goes. So we're drawing a line between the current and previous positions of the mouse. And P mouse X is just basically exactly what it sounds like. Mouse X, mouse Y is wherever the current mouse is, and P mouse X, P mouse Y is the last position that the mouse was in. And so that's useful for making a drawing program if you wanted to make something for people to draw or add graphics to. So our next system variable is the frame count. And this, we saw a little preview of this earlier. It's just whatever frame, the current, how many frames it's been since the program started. And so we can see an example here where I'm using the frame count to change the size of the ellipse. And so this example is pretty similar. We've just got the X is half the width, so our ellipse is in the middle of the canvas, the Y is half the height, and then I'm just setting size here directly to the frame count. And so you can see the ellipse is just growing as our sketch continues, and it's just gonna keep getting bigger and bigger until it takes up the entire screen. So that's our frame count. We probably won't use the frame count for animation because there's better ways to do it, but it's a useful thing to be able to have. So one more quick note. So we didn't set these values. We just kind of said like, this is, we just kind of reference these values. So we just say width and height. I'm not saying like variable height equals 0 at any point or variable frame count equals 0. These are things that P5 is just doing for us. P5, like when we call setup, is doing a bunch of things like creating the canvas and setting up our width and height. And when we do that, it saves and it creates all these system values for us that we can use as we're working with our sketch. All right, so that's just it for system variables. I do want to go back to this thing about scope, and I want to redo this first example using X, because that will make a little bit more sense. So that's the last thing I want to do, and then we'll move on to the next bit. Okay, so as we saw before, I had this ellipse where I was using the frame count as the X value. Okay, and so there goes our ellipse. So another way that I could do this is by using a variable, and I would probably use like the variable X. So I could say something like variable X equals frame count, and then put X in here. And so we can see that X is being assigned to the frame count. And let's actually look at X. So I'm going to put a text value with X in it. And I'm going to put this in the top left corner. So you can see that X is changing. It's changing to the frame count. Let's make that a little bit bigger. And it's moving very fast. But let's see if I change the frame rate. Another P5 function that I don't think we've used before is I can actually change the frame rate. So let's change it to something really slow, like 2. This is 2 frames per second. So we're going to see it only updates every half second. So we can just see it moving really, really slowly. And you can see that the frame count is just going up every time we draw the canvas. And our circle is slowly moving across the screen. So another way to do this is to declare X and then increment X so it's not tied to the frame count. And that's not really necessary for what we're doing today, but it will become very necessary in a couple weeks when we look at some more sophisticated ways of doing animation. But for now, let's say we have variable X equals 0. And so now X is not moving. It's just standing still. But if I say every frame X plus plus, so that's going to add 1 to X. Now we can see we're moving again. And let's increase our frame count so we can see it going a little bit faster. So now in our draw frame, we don't need the frame count anymore because we're just adding 1 to X every single draw. And so now every time we draw, we add 1 to X and the ellipse moves across the screen. So the thing I want to talk about is the concept of scope. Okay, so this X up here, this is called the global scope. And when something's in the global scope, it can be used in either the setup or the draw function. So for example, if I want to change X in setup, I can say X equals 50, and that's going to make our X value start at 50. If I change the X value to 100, it's going to start at 100. And I can also use width here. Since I've already done create canvas, I could say X equals width over 2. And so now our circle is going to start in the middle. And so this is a global scope. So we can set X here. If we create a variable inside of setup or draw, it's going to be scoped to that function. And so JavaScript acts in kind of in weird ways with this. So we'll kind of go over other examples of this later. But what I want to show you, the main thing I want to show you here is if I declare variable X equals 0 inside of draw, it's not going to work the way I want it to. So notice that X is just staying at 1. Because essentially we're saying variable X equals 0, we're drawing the ellipse, we're incrementing X, so it does become 1. But then with our draw function, after we draw 1 frame, on the next frame, we just go back to the beginning of draw. So we draw our background again, and now we're resetting X to 0. So that's why a lot of the time, if I have a value like this that's going to change over time, you're going to see it's at the top of my program in the global scope. So this is called like a function scope or a local scope. And so there's other issues that this creates that we'll talk about later in the semester. But for now, that's the main thing that you need to know is that if we're using variables that we want to change over time, most likely we're going to need them to be part of the global scope and not in our draw function where they're going to be sort of reset every time we go through draw. So I'm going to uncomment this. And so now we'll see that X is working again the way we want it to. Okay, so I think that is the last note I wanted to cover here. So we've learned a little bit about using width and height and our system variables. What we're going to do tomorrow is go over interaction. So we're going to learn some cool ways to kind of apply those variables to our sketch to make it interactive. For today, if you guys want to start playing around with those variables, you can. If you're still working on the variables version of your self-portrait, you can also work on that as well. And yeah, so if you're done with the assignment 3, you can start thinking about adding in the variables width and height and mouse X and mouse Y into your self-portrait project. Okay, I'm gonna stop